Alrighty, welcome back, boys and girls. It's your man, Mathematics Shen, coming to you live from Summit Academy. In this video, we're working on that unit number 7, lesson 12 now. Still talking about that scientific notation and placing them on those number lines. And so what we're going to be able to do is going to use powers of 10 to make calculations with large and small numbers. So the first part says, what information do you need? So what information would you need to answer the following questions? So how many meter sticks would it take to equal the mass of the moon? And it says if all meter sticks were lined up end to end, would they reach the moon? So what we could say first is we need to say we need to know the mass of the moon and the mass of the meter stick. Then we would say for the second part, we would say we need to know the distance to the moon. So just a couple different things we need to figure out before we can calculate that. So now let's say if we do figure out what those calculations are, it says how many meter sticks does it take to equal the mass of the moon. So what we can do is we're going to do a little bit of division here. So we're going to say we have 7 times 10 to the 22nd power, so 22, divided by 2 times 10 to the negative 1 power. So now that we have that same kind of base, through division we can subtract the exponents. So what this is going to be equal to is we can do 7 divided by 2 times, and we have 10 to the 22nd power minus a negative 1. So you got to be careful when you're working with those same sign, meaning both negative. When I say that is just like we're adding it, so that's going to be equal to 3.5 times 10 to the 23rd power. We're going to label that as point. Let's label that as point M. So now it says to label the number line and plot your answer for the number of meter sticks. And so what we're going to do is we're going to label this far right one. We're going to label that 10 to the 24th power, because each of these tick marks is going to be 1 times 10 to the 23rd power. So when you're labeling these, just make sure that you're using the appropriate exponent, so that way it's a logical increment, meaning each of these tick marks should just be, one step at a time. We have 5 times 10 to the 23rd, we have 6 times 10 to the 23rd, 7 times 10 to the 23rd, 8 times 10 to the 23rd, and 9 times 10 to the 23rd. Okay, so we should have some practice with this by now, but we need to now plot our answer. So we're going to plot this point M on here. So let's plot this point M, and I'll do it in orange here. So since it's going to be 3.5 times 10 to the 23rd, we can put it in between 3 and 4. So we're going to put it right there and label it M. Then for the number 3, it says if you took all the meter sticks from the last question and lined them up end to end, will it reach the moon? So we're going to say it'll be about, we're going to say it's going to be about 10 to the 15th power. We'd say because we do 4 times 10 to the 23rd is 10 to the 15th times larger, I would say as much. Let's say as much as 4 times 10 to the 8th power. So notice how we're using those exponents to get our answer. So it's almost like we did 10 to the 15th plus 10 to the 8th to get our 10 to the 23rd. Then for number 4, it says 1 light year is approximately 10 to the 16 meters. How many light years away would the meter sticks reach? So we're going to label our far right point. We're going to label our far right point as 10 to the 8th, because we're going to label, we're going to say 3.5 times 10 to the 7th is going to be equal to our point M again. So now that you have that far right point labeled as 10 to the 8th, we can label each of these points 1 times 10 to the 7th. So each of them are increasing by 1. So we keep the same times 10 to the 7th power for each of those points. And we're going to label our point M on our graph. So since 3.5, again, it's going to be in between 3 and 4, and we label that as point M. So just make sure, again, even though it looks like it's the same point on the graph, these exponents are very different, so we have to make sure that we are careful about those values. Then for the next part, it says in 2016, the Burj Khalifa was the tallest building in the world. Consider the following questions: which is taller, the Burj Khalifa or a stack of money it cost to build the Burj Khalifa? So for number one, it says, what information would you need to be able to solve the problem? So we would need the height of the Burj Khalifa, the cost of it, and the height of the money stack. And so what we can do is we're going to find each of those. I'm going to give those to you. So I'm going to give you each of these values. So it says the Burj Khalifa is 830 meters. The cost was $1.5 billion. And it says 1 meter stack of hundreds is $1 million. So then it says for the next one, for number 3, it says, which is taller, the Burj Khalifa or a stack of money it costs to build the Burj Khalifa? So we're going to say for this one, what we can do is, let's do it like this. So let me use blue. And so what I'm going to do is I'm going to say I have 1.5. I'm going to take 1.5 times 10. Let's do times 10 to the 9th power divided by 10 to the 6th power. And so again, since we're dividing with the same base, we can subtract the exponents. So this is just going to be 1.5 times 10 to the exponent of 3. And so what we can say from that is this. We're going to say the stack of cash is about twice as tall as the Burj Khalifa. Then for the next part, it says decide what power of 10 to use to label the rightmost tick mark of the number line and plot the height of the stack of money and the height of the Burj Khalifa. So I have 2 different points on here, and what we can do is let's first plot out. So I'm going to do the same thing as before, plot out our right point. So we're going to say our far right point is 10 to the 4th, and so that means each of these are going to be 1 times 10 to the 3rd. So for each of them, it's 1 times 10 to the 3rd, one step at a time. So 3 times 10 to the 3rd, 4. I can draw it out. 4 times 10 to the 3rd, 5 times 10 to the 3rd, 6, 7, 8, and 9. So notice how I have times 10 to the 3rd power for each of those, because we're talking about that scientific notation. And so what we can do is we're going to label our different points. We're going to say that cost is going to be that point C. So that cost is going to be the point C. And we could put that, since, let's label this as C. So this is going to be, let's say, in between 1 and 2, because that's where 1.5 is. And then we can label our cost BK, or not our cost, our length of BK. It's going to be still below 1, so we're going to label that down here and say that's going to be BK. So that's going to be the Burj Khalifa. Then for number 5, it says, which has more mass, the Burj Khalifa or the mass of pennies it would cost to build the Burj Khalifa? So what we're going to do a couple calculations with this. We're going to say the mass of BK is going to be like this. We're going to say it's going to be equal to, we're going to say 4.5 times 10 to the 8th power. And we're going to say that the total mass of pennies is going to be 2.5 times 10 to the negative 3. And we have times 1.5 because of that 1.5 billion. times 10 to the 11th power. And so what we have to do is we have to multiply those exponents together. So what we're going to say is we're going to multiply these together, and we're going to get 3.75 times 10 to the 8th power. And so what we have is this. We're going to say that the mass of the Burj Khalifa is more than the total mass of the pennies. So just make sure that you're multiplying the same bases together. You can add the exponents. So we have negative 3 plus 11 give us positive 8. Then for the last one on this problem, on the back, it says decide what power of 10 to use the label of rightmost tick mark on the number line and plot that mass of the Burj Khalifa and the mass of the pennies it would cost to build the Burj Khalifa. So again, we're going to say far right point is going to be 10 to the 9th power. And for each of these, it's going to be 10 to the 8th power. So we have 1 times 10 to the 8th power, 2 times 10 to the 8th power, we got 3, 4, 5, 6, 7, 8, and 9 times 10 to the 8th power. So each of those are being multiplied by 10 to the 8th power, since that's what our original problem was from before. And so now what we have to do, again, we make sure you plot these points out. So we're going to say, again, the mass of those pennies was that 3.75. So we're going to say, let me write these down from before, we're going to say that BK was 4.5 times 10 to the 8th power. And we also said that the pennies, that point P, is going to be equal to 3.75 times 10 to the 8th power. We're going to plot these 2 points out on our number line. So in between 5 and 4 is where we're going to put BK in. And then we have for our value of the pennies is going to be 3.75. So we're going to put that in between 3 and 4, but a little bit closer to the 4, and label that as P. All right. So now for those practice problems, it looks like this. It says, which is larger, the number of meters across the Milky Way or the number of cells in all humans? So it gives us some useful information, and what we can do is we can rewrite some of these in terms of the scientific notation. So we're going to say this is going to be the same as the 10 to the 5th power. We can say for the next one, it says there are 37 trillion cells in the human body. So we're going to say that this is going to be the same as 3.7 times 10 to the exponent of 13. So let me actually write that on the side here. So let's say this is going to be 3.7 times 10 to the exponent of 13. And it says 1 light year is about 10 to the 16 meters long. And it says for the population is about 7 billion. So that's going to be the same as 7 times 10 to the exponent of 9. All right, so first what we're going to find is we're going to say, let's find the, let's do blue. I'm going to say meters, try that again, meters across the Milky Way. So in order to do that, we're going to figure it out. So we have 10 to the 5th power times 10 to the 16th power is going to be equal to 10 to the 21st power. Again, make sure you're adding those exponents together to get 5 plus 16 is 21. Then we could say for our cells, however, when we find our cells, we're going to say that's going to be 3.7 times 10 to the 13th power. And we're going to do times the number of people in the world. So we have times 7 times 10 to the 9th power. Again, since we have those same bases with 10 and their exponents, we can add those two exponents together. So we're going to have, it's going to be 25.9 times 10 to the 22nd power. And what we can say in conclusion then is that there are going to be more cells than meters across the Milky Way, which is a large distance. Then for number 2, it says Diego was solving an equation, but when he checked his answer, he saw his solution was incorrect. He knows he made a mistake, but he cannot find it. So it says where is Diego's mistake and what is his solution to his equation. So if we look at each of these like this, we're going to say, okay, this is going to be the original equation. And then the steps after that are going to be the steps of work that I did. So this is step 1, this is step 2, this is step 3, and this is step 4. And so what you have to do is you have to be able to find, which step is the result incorrect at. And what we're going to say is this. We're going to say Diego made a mistake in step 1. And what that mistake is, we can say he distributed incorrectly on the left side. And so what we can do is we can show our work and see what we get. So we have the original equation. We have -4 times quantity 7 minus 2x equals 3 times x plus 4. And so what we can do is we can do that distributive property on the side here. So I have my little box I can draw, and I can say, okay, if I have a -4 on the outside, and I'm multiplying times a +7 and a -2x. So I multiply each of these together, so -4 times 7 is going to be -28, and -4 times a -2x is going to be +8x. And whatever I get inside the box is what I write underneath. So I have -28 plus 8x equals, and then we're going to say we have 3 times everything inside the parentheses. So we have +1x and a +4. So this is just going to be +3x and +12. So I have 3x plus 12. Now that I have variables on both sides, I can find which coefficient is lower, and I'm going to get rid of it. So I have 8x and a 3x, so I'm going to subtract 3x from both sides because I need to get the variables on one side. Now I can say on my left side, I have -28 plus 5x equals, and then on my right side, I just have 12. Now that I have all the variables on one side, I can get rid of the constants. So I want to get rid of the -28 by adding 28 to both sides. On the left side, I just have 5x. And on the right side, I have 40. Last step is to always divide by that coefficient. So divide by both sides by 5, and we get x equals 8. But now what I want you to do is, how do you know this is true? I want you to pause for your turn, and I want you to check the graph on Desmos. So make sure you're remembering how to do this. So you type in your one side of your equation. So you would type in y equals, and then you'd have -4 times the quantity 7 minus 2x, and then your other side is going to be the right side. So you're going to say y equals 3 times quantity x plus 4. So find where they intersect and check your answer. And then for the last one, for number 3, it says 2 triangles are similar. Find and solve for x. So what we can do is say this. We can say similar triangles mean the corresponding angles are the same. Then we also know that when we add up the 3 angles in a triangle, it's going to be equal to 180. So what we're going to do is we can write this equation out. We're going to say that we have 46 is the same as here, and also 106 is going to be right here. So we're going to say that this is going to be 106, and we just need to solve for x. So what we're going to do is we can write it like this. The sum of those angles in a triangle is going to be 180. So we have 180 equals 46 plus 106 plus x. So then we can simplify. So I do 180 equals, add these two together. So that's going to be 152 plus x. Then I can use one-step equation to solve for x. So I subtract 152 from both sides. Now I can say on my left side, I just have 28 degrees. I'm going to say that's going to be equal to x. So our solution for that one is going to be 28 degrees. So make sure you can ask questions as they come up. And as always, super slam that subscribe button.